what's up, YouTube fans? So what I want to talk about in this video, right, is something relevant to the reducibility of our arms and hands and our legs and our feet. You know, I've talked a lot about that in other videos. I've talked about things like such as how, you know, our arms and hands are basically just modified legs and feet, right? Right, which became modified into arms and hands as our ancestors began tree climbing, right? And then in the human lineage, they became specialized towards tool making, right? But so there's something relevant to the reducibility of the hands and the feet, right? Is that it didn't have to always from the beginning be where there's space between each individual finger and each individual toe, like space that's not filled in with skin, right? It didn't have to always be that way, as opposed to it being like webbed, right? And there's a lot of evidence in regards to that, right? So, what is that evidence? Well, first off, in early tetrapodomorph fish that were evolving into tetrapods, there's a number of fossils for the transition from fish to tetrapod. And what fossils indicate, right, is that the phalanges first got started in inside of fins, right? So that's the first line of evidence, right? And then as another line of evidence, right, we see in many groups of tetrapods that that each individual finger and each individual toe is filled in with skin, right? Like the space in between is what I mean to say. We see that in many groups of tetrapods alive today, you know, like many amphibians, like many frogs will commonly have webbing between their toes, right? And we see that, you know, whales have the space between each individual I don't know if it would be called finger or toe on them, but it's all filled in, right? Because they have fins, right? And then that's also what we see in bats, right? Bats have fingers, right? And that's clear to see, right? When you see their skeleton, right? That it looks like as if they have fingers, right? But it's all filled in, right? And it's performing the function of a wing, right? Same deal with birds. The bird wing is different from the bat wing, but same deal, right? It's filled in, right? And this what's more, so even in us humans, right? Even though for us, we the normal setup for humans is not to have webbing between our fingers and webbing between our toes. There actually is a condition, right, where a person can be born like that, right? So that a person could actually be born where they have like skin filled in between their fingers or between their toes, right? And so they're like, their fingers and toes are like glued together, essentially, like not glued, not like literally glued, but they're like fused together, right? With skin in between, right? And so, the condition of having like, there not being skin filling them in, like filling in between each finger and toe, that can come as a later, adaptive change, right? As, our ancestors adapted towards, you know, terrestrial life, eventually, arboreal life when they started living in the trees, right? And so it doesn't even need to always have been the case that there's space between each digit, right? Digits refers to both fingers and toes, right, are together called digits. And I've talked about this on other videos, I think, right, that most of the same genetic instructions can be used for each individual finger and toe, right? And part of how we know that, right, is that there are conditions, right, where a person could be born with extra fingers or toes. So like 6 fingers on one hand, 6 toes on one foot. And in many cases, they're all still functional, right? So all fingers still functional, all toes still functional, mostly set up the same still. And that is an inheritable condition. So oftentimes when people with that condition go on to make a baby, the baby comes out the same way, right? And so it's not like the genetic instructions for each individual finger and toe had to be completely evolved from scratch. Most of the same genetic instructions can be used for building each individual one, right? And also even for each individual limb, right? Because bilaterally symmetrical animals like us, where our left side mirrors our right side, most of the same genetic instructions are used for much of the left side and the right side of the body. It's like reused, right? So that's the same reason why with like our eyes, our left eye and our right eye they obviously didn't need to each be evolved independently from scratch. Most of the same genetic instructions are used for each of them. And with the front limbs and the back limbs, it's also most of the same genetic instructions. And part of how we understand that can be possible, right, is because of body segmentation, right, which is something that we find in most bilaterian animals, including vertebrates, and therefore including tetrapods, and therefore including humans, right? And it's where there's like the body is divided into a repeating series of segments. And then there's something called the Hox genetic code, right, which works together with these segments. And it basically works in a type of way where like differing body parts can be positioned more than once across the body. And the segmentation helps with determining the positioning. And there's certain experiments that have shed light on how this works. Like one of the first ones was the Drosophila fly experiment, where they showed that mutating the fly's genes in a certain type of way could actually result in the fly having legs coming out of its head where its antennas should be, right? Because so not only are there genes that determine the setup of various body parts, the structure of them, there are also genes that determine the positioning, spatial positioning of body parts relative to each other. And so therefore mutating those genes can change that, and it can lead to the same traits being reused in more than one area across the body's axis, right? And so for each individual limb, most of the same genetic instructions are used. It didn't need to be evolved independently from scratch, right? And of course, we see simpler limbs, right, which are also fins in the lungfish and the coelacanths, which are the closest living relatives of tetrapods, right? And so the tetrapod lineage took the same structures that they had, further adapted it towards terrestrial life, right, life on land, through the course of mutation and natural selection. And so, yeah, that's all for now. See you guys.